In the dim morning hours near Lille, a lone figure moved east through open fields, adjusting his pace with each train whistle in the distance. The route was memorized. There could be no maps, no signs, no mistakes. Failure to arrive on time meant exposure. But beneath the wrist, a silent object ticked, not just to mark the hour, but to preserve the mission if capture became inevitable. By the early years of the Second World War, clandestine operations behind enemy lines had become a routine necessity rather than an exceptional risk. Agents were inserted into occupied territory to observe rail movements, identify industrial targets, establish resistance contacts, and relay information by radio or courier. These tasks depended on remaining unnoticed for extended periods, often while moving alone through unfamiliar terrain. Contemporary accounts suggest that the greatest threat to such missions was not combat but interruption, arrest at a checkpoint, a random document inspection, or an informant's quiet accusation. The problem was not new. Espionage had always carried the risk of capture. What changed between the wars was scale. Occupied Europe became saturated with security forces, border controls, and internal travel restrictions. Rail stations, roads, and even rural paths were monitored. Identity papers were scrutinized with increasing sophistication. In this environment, evasion depended on constant movement and precise navigation. An agent who missed a rendezvous or lost their way could not simply wait. Delay itself attracted attention. Navigation, however, was not a trivial matter. Civilian maps were often outdated or deliberately altered. Military maps, where available, were incriminating to carry. Compasses were useful but conspicuous, particularly when concealed poorly or examined during a search. Period training manuals indicate that agents were expected to orient themselves quickly, often at night, using minimal equipment. Losing one's bearings could mean stumbling into a controlled zone or failing to reach a safe house before curfew. Capture carried consequences beyond the individual. Interrogation techniques employed by occupying forces were systematic and, by modern standards, severe. Documentation implies that even well-trained agents could eventually be broken under sustained pressure. Names, locations, radio frequencies, and schedules were all vulnerable once an operative was detained. The arrest of a single courier could unravel an entire network within days. From the perspective of planners, the problem was not merely survival, but containment of damage. Existing methods to address this risk were limited. Agents were trained in resistance to interrogation, including the use of cover stories and compartmentalization of information. They were instructed to memorize details rather than write them down, and to destroy notes at the first sign of danger. Some carried false documents of increasing quality. None of these measures, however, were reliable once physical custody was established. A thorough search could reveal hidden items. A prolonged detention could expose inconsistencies. Training reduced risk but did not eliminate it. There was also the question of choice at the moment of capture. Some agents attempted escape with outcomes that were unpredictable. Others relied on the hope of rescue or exchange, possibilities that records suggest were rare. A few accounts refer to individuals who chose to end their own lives rather than submit to interrogation. These decisions were personal, but they were also shaped by institutional expectations. The idea that an agent might need a final means of control over their fate was discussed, albeit cautiously, in internal correspondence. Traditional suicide methods were problematic. Firearms were rarely issued to deep cover agents, as they attracted attention and were difficult to justify if discovered. Bladed weapons were unreliable and slow. Poison had historical precedent, but carrying a vial or capsule presented obvious risks. Such items could be found during a search, raising suspicion even before arrest. There was also the danger of accidental exposure, particularly under stress or during physical exertion. The psychological burden of these realities was significant. Agents operated with the knowledge that mistakes were often irreversible. The constant need to appear ordinary while managing navigation, communication, and surveillance tasks created cumulative strain. Contemporary training assessments note fatigue, disorientation, and lapses in judgment as recurring issues. An operative who became lost or delayed was more likely to make visible errors, increasing the chance of detention. Attempts to mitigate these risks through procedural changes met limited success. Shorter missions reduced exposure but also limited intelligence value. Larger teams offered mutual support but increased visibility. Reliance on local guides introduced dependency and the possibility of betrayal. Each adjustment solved one problem while creating another. The underlying issue remained: how to equip an individual agent to navigate hostile territory, avoid capture, and if capture became unavoidable, prevent the compromise of others. By 1941 and 1942, this problem had become acute. Occupying authorities refined their counterintelligence methods, while resistance networks grew more complex and interdependent. The margin for error narrowed. Records from the period suggest a growing recognition that existing practices were insufficient for the conditions agents now faced. Yet any new approach would have to meet strict constraints. It must be concealable, innocuous under casual inspection, and usable under extreme stress. At this stage, the problem was clearly defined but unresolved. How could an agent carry essential navigational capability without drawing suspicion? And how could they retain a final safeguard against catastrophic compromise without introducing new dangers? The answers to these questions were not immediately apparent, and early discussions stopped short of proposing concrete solutions. What followed would involve institutions, engineers, and planners confronting these constraints directly. But that development lay ahead, beyond the problem as it was first understood. By late 1942, the challenge of providing field agents with both discrete navigational tools and a last resort self-termination option had gained greater urgency among Allied intelligence circles. While no single memorandum marks its beginning, fragmentary references in SOE, Special Operations Executive Planning documents, and OSS, Office of Strategic Services correspondence suggest that the issue was being raised in parallel across multiple departments. The discussions were unofficial at first, reflecting the sensitivity of the subject matter. The introduction of any device intended to facilitate suicide risked political, operational, and ethical complications. Nevertheless, reports from captured or compromised agents underscored the need for a quiet re-evaluation of the tools carried in the field. MI6 and SOE field branches began to request equipment that could withstand close examination by enemy personnel. Several incidents are cited where traditional compass devices, whether concealed in buttons, belt buckles, or cigarette cases, were confiscated during search procedures and led to the agent's exposure. In occupied France, a compass hidden in a map case was reportedly identified by a German checkpoint officer who had undergone specific training in contraband orientation devices. The operative was arrested within minutes. The SOE's technical section, sometimes referred to as Station 9, located near Welwyn in Hertfordshire, was already tasked with developing clandestine tools for sabotage and evasion. Documentation implies that by early 1943, a subset of its engineering staff began experimenting with ways to combine multiple functionalities into a single, concealable object. The target was dual, a navigation aid that could pass for a civilian object and a suicide mechanism that would remain undetected during casual inspection. Early conceptual sketches centered on everyday personal accessories: lighters, buttons, fountain pens, and wristwatches. The wristwatch, in particular, attracted focused attention. It was both common and practical, unlikely to arouse suspicion even during secondary questioning. Furthermore, field agents were already trained to synchronize movements and time rendezvous, giving the object plausible deniability. Period design files suggest that several SOE engineers believed a modified watch could offer cover for a hidden compartment, small enough to avoid notice, but accessible under duress. This solution, however, was far from straightforward. Initial prototypes attempted to embed a magnetic compass beneath the dial or within the strap buckle. These were based on commercial models sold in Switzerland during the interwar period, often intended for hiking or amateur exploration. Yet integration proved difficult. Traditional compass needles required space to rotate freely, and magnetic interference from the metal watch components often skewed readings. Trials conducted at Station 9 reportedly produced inconsistent results, especially when the device was exposed to heat, cold, or movement. Miniaturization alone was not sufficient. A new configuration would be required. Simultaneously, another set of engineers explored the feasibility of concealing a lethal capsule within the watch case. The compound under consideration, most commonly potassium cyanide, was chosen for its rapid effects when taken orally. However, this raised immediate problems. Cyanide is highly reactive and unstable in moist environments. Watches, by design, come into frequent contact with perspiration, condensation, and temperature changes. Sealing a capsule within such a device without risking degradation or leakage required airtight containment far more advanced than the consumer-grade gaskets available at the time. Further complicating the process was the issue of accidental activation. A hidden pill that dislodged during a fall, or broke during a struggle, could end the life of the agent prematurely. Engineers debated the safest mechanism for deployment: screw-off backs, pressure triggers, magnetic latches. Each presented risks. Internal SOE minutes from March 1943 refer obliquely to an unacceptable failure rate during early live trials of a capsule-integrated timepiece. No additional detail is preserved, though it appears that further development was paused for several weeks. By mid-1943, other organisations became involved. The American OSS, in coordination with the British, had begun parallel efforts to equip field operatives in North Africa and Southern Europe. American documents reference a short-lived collaboration with the Hamilton Watch Company and a New Jersey-based precision toolmaker, although no production units are known to have survived. OSS engineers reportedly faced similar difficulties with magnetic shielding and chemical containment. Alternative ideas were trialled and rejected. One concept involved a breakaway charm worn on a bracelet, containing a glass ampule of poison. Another explored the use of hollowed-out cufflinks, though these offered limited space and required awkward handling. The notion of embedding equipment in a ring was also floated, but dismissed due to the high likelihood of discovery during body searches, which frequently involved removal of jewellery. As these options failed to yield a workable field solution, attention returned to the wristwatch. In a July 1943 briefing note from Station 9, since partially declassified, a proposal was raised to separate the navigational and self-destruct functions, but house both within the same device to reduce the overall equipment profile. This marked a shift from earlier thinking, which had treated each problem in isolation. The idea was to embed a directional aid that could be accessed discreetly through the watch face, and to conceal a small cyanide capsule within the inner rim of the case or band clasp. Early reactions within the department were mixed. Some questioned whether combining the two would reduce the effectiveness of either. Others raised operational concerns. What if an agent mistakenly ingested the compound while attempting to retrieve the compass? What if the mechanism jammed under duress? Records show that a design team led by a mechanical engineer known only by the alias MG was authorized to build and test an initial production prototype. The constraints were absolute. The watch must be indistinguishable from a civilian model, must function as a basic timepiece, and must contain both a usable compass and a stable lethal capsule. What followed over the next several months was a meticulous process of compromise, experimentation, and partial success. Materials were tested, components reshaped, internal layouts reconfigured. Small-scale field evaluations were conducted under controlled conditions, though it remains unclear whether these included live agents in hostile territory. Surviving documents from the autumn of 1943 describe a Mark II version that showed promising concealment characteristics and improved environmental resistance. Details of its construction were kept deliberately sparse in official records. By winter 1943, it appears that the project had entered a limited production phase. How many units were made, who received them, and under what operational protocols? These questions remain unanswered in surviving documentation. What is clear, however, is that the wristwatch device had moved beyond theory. It now existed as a physical object, an ordinary-looking accessory containing extraordinary consequences. The final design of the wristwatch compass containing a cyanide capsule represented a convergence of engineering precision and grim necessity. It was never intended as a mass-issued item. Surviving requisition notes and workshop ledgers indicate that each unit was hand-assembled, often modified to the specifications of individual operatives or field missions. The technical reasoning behind the design's compact dual functionality reveals both the ingenuity and the limitations imposed by wartime materials science. The watch itself was based on a civilian mechanical model, commonly sourced through neutral Switzerland, and subtly altered by SOE and OSS engineering teams. Several Swiss manufacturers, long known for their discretion, were indirectly involved in supplying components, though it remains uncertain whether any were aware of the watch's ultimate configuration. The exterior of the watch was deliberately unremarkable. It bore no military markings, featured standard Arabic numerals or minimalist indices, and utilized stainless steel or nickel-plated brass cases designed to mimic commercial models in circulation across Europe. The compass mechanism was the most significant internal modification. Instead of a full rotating needle suspended within a fluid-filled case, which would have required both depth and diameter incompatible with a wristwatch's dimensions, engineers adopted a pivoted disc design. This method reduced the compass to a thin circular plate with a magnetic orientation, suspended under the watch face in a low-friction housing. In most configurations, the disc sat beneath a hinged or removable dial plate. When the user released a concealed catch, often hidden within the crown or under the band clasp, the face could be lifted to reveal the directional element beneath. This system had limitations. Due to the shallow depth, the compass lacked the damping fluid typically used to stabilize needle movement. Field notes imply that the device could not be relied upon during motion or vibration. Users were instructed to remain stationary, level the watch on a flat surface, and allow the disc to settle before attempting to orient themselves. Furthermore, magnetic shielding was partial at best. The watch's movement components and external metal housing required non-ferromagnetic materials to prevent interference, which increased both cost and manufacturing time. Despite these constraints, reports from training courses at SOE facilities suggest the compass was regarded as acceptable for short-distance orientation, sufficient to reach a landmark, cross a field at night, or identify cardinal direction under cloud cover. The primary advantage was concealment. Because the mechanism was housed entirely within the watch's structure, even a careful search by an enemy patrol was unlikely to detect it unless the watch was dismantled. The second function of the device was more severe. Encased within a false cavity along the inner rim of the watch back, usually behind a screw-down secondary plate, was a small sealed compartment containing a lethal capsule, typically composed of potassium cyanide or a cyanide salt combined with a rapid-release buffer. The capsule was housed in a glass ampule or wax-coated gelatin container, designed to be crushed between the molars when bitten. To access it, the agent would need to remove the watch, unscrew the back using a coin or fingernail, and detach the internal cover to reach the compartment. In some variants, particularly those issued in 1944, the capsule was stored in a hollowed-out clasp pin on the wristband, sealed with a press-fit brass cap. This allowed for quicker access, though it introduced greater risk of accidental discovery or activation. Material selection was critical. Cyanide is highly hygroscopic, meaning it absorbs moisture from the air, which can degrade the compound or reduce its effectiveness. To counter this, the capsules were sealed with paraffin wax or enclosed in waterproof celluloid sleeves. Declassified test logs from Station 9 mention storage stability testing in variable temperature and humidity conditions. Period testing indicates the capsules retained efficacy for approximately 6 months under average field conditions, though reliability beyond that point is unclear. The triggering mechanism relied entirely on manual access and voluntary ingestion. No timed or automated release system was incorporated, nor were pressure triggers considered acceptable, due to the risk of unintentional deployment. The design philosophy appears to have been consistent with broader SOE and OSS principles. Tools should never take initiative away from the agent. The decision to use the capsule remained fully under human control, even in moments of extreme duress. From a technical standpoint, the design success lay not in perfection but in compromise. It was never meant to outperform military-grade navigation tools or function as a foolproof failsafe. Rather, it offered a final layer of utility to operatives working alone, unarmed, and without reinforcement. In doing so, it embodied the stark arithmetic of clandestine warfare. When escape was impossible and silence more valuable than survival, a solution, however improvised, was required. Manufacturing was conducted in small batches. Each unit was individually tested, often without the capsule installed, to verify compass orientation and structural integrity. The toxic element was usually added only days before deployment, under controlled conditions at secure logistics sites. Instructors emphasized discretion and self-reliance in training sessions. There were no instruction manuals, no labels, no identifying features. An agent receiving the watch might be told only once how to use its hidden functions. Redundancy was discouraged. The watches were stored in padded containers, often alongside forged documents, local currency, and false ration cards. Deployment logs are fragmentary, but suggest that devices were issued to agents operating in France, Belgium, and the Balkans during late 1943 and early 1944. No standardized model number was assigned, and individual units varied based on the preferences of the engineer assembling them. Surviving examples are scarce, and their provenance often difficult to verify. Most were likely destroyed or lost in the field. Technical illustrations from the period show a quiet pragmatism behind the device's construction. There are no ornamental engravings, no flourishes. Even the timekeeping mechanism itself was left deliberately imprecise. Time accuracy was less important than plausibility. The watch needed only to look and behave like a civilian accessory, not to withstand laboratory scrutiny. What emerged from this convergence of necessity and ingenuity was not a marvel of engineering in the traditional sense. It was a tool, harsh and efficient, built for a narrow purpose, to extend an agent's freedom of movement and to preserve operational security if all other defences failed. Once the wristwatch device entered field circulation, its true test began, not in workshops or training grounds, but in the unpredictable and often unforgiving conditions of occupied Europe. Surviving records indicate that its deployment was highly selective. It was not standard issue for all agents. Instead, it was reserved for operatives assigned to deep cover missions with high likelihood of isolation, exposure, or capture. These included courier routes in northern France, sabotage coordination in the Low Countries, and liaison roles with partisan units in Yugoslavia and northern Italy. The operational use of the device was, by design, quiet. There was no ceremony in its issuance. Agents were often given the wristwatch shortly before departure, with a verbal explanation from their handler. In some cases, written references suggest that the cyanide capsule's presence was not explicitly confirmed. The policy of implied availability meant that not all users may have known the full extent of the watch's capabilities. This ambiguity itself was part of the operational security strategy. The compass function appears to have been the more frequently utilized feature. SOE after-action reports from France describe agents navigating hedgerow country at night, or crossing forest boundaries in Belgium, using the concealed watch mechanism to establish direction. These entries are rare and vague, but enough to confirm that the compass was operationally viable under ideal conditions. It was not a substitute for field maps or local guides, but it allowed for brief directional alignment in moments where traditional tools were too risky to carry. Field agents often moved on foot for miles, frequently at night or under cloud cover. The ability to orient quickly, without unfolding a map, lighting a match, or removing an obviously military object, could mean the difference between arriving at a safe house or walking into a Gestapo checkpoint. The watch's compass, crude as it was, served this purpose in a manner that drew no attention from enemy patrols. It was, according to one debriefed agent, the only tool you could wear while being questioned. More sensitive is the subject of the capsule. Official records offer few direct references to its use in the field. This is unsurprising. Agents who activated the capsule left no opportunity for recovery or post-mortem report. In the few cases where a watch was retrieved from a deceased agent, the device itself was either destroyed, missing, or disassembled by enemy forces. However, captured German documents, especially from Sicherheitsdienst (SD) and Abwehr units operating in France and the Netherlands, occasionally reference unexplained fatalities during prisoner transport or in holding cells. One such report from early 1944 describes a female detainee who collapsed within moments of being restrained, with no evidence of weapon use or physical trauma. The body was removed before medical inspection. No watch is mentioned, but the timing and circumstance suggest the possibility of capsule use. There are also at least 3 post-war testimonies, 2 from fellow resistance members, one from a liberated SOE officer, describing individuals who bit something after capture. In each case, death was rapid and unattended. These accounts remain anecdotal and lack forensic verification, but they support the notion that, while rare, the suicide function of the wristwatch was indeed employed when compromise became inevitable. Enemy reactions to the discovery of such devices were often fragmented. German counterintelligence agencies were familiar with the use of concealed tools and poison capsules from earlier conflicts. Hollow coins, false teeth, and pen guns had all been documented by mid-1943. Yet the integration of such functions into a common timepiece appears to have surprised even experienced search teams. A 1944 Abwehr report from Paris lists a suspicious wristwatch containing irregular components, seized during a raid on a safe house. No chemical analysis was performed. The watch was sent to Berlin, where its trail ends in a storage inventory. This lack of consistent detection worked in the Allies' favour. While the existence of the device remained largely unknown to German units, its presence altered the psychological calculus for Allied agents. The knowledge, real or implied, that a final option existed in the event of capture helped maintain operational silence in high-pressure situations. Even for those who never used it, the capsule represented a form of personal control in an environment where almost everything else could be taken away. There are, however, indications that enemy forces began adapting their protocols in response to suspected cyanide use. Reports from late 1944 describe more aggressive and immediate physical searches, often involving forced ingestion of water, induced vomiting, or the binding of prisoners' jaws. In some cases, prisoners were rendered unconscious before interrogation to prevent the use of suicide tools. These countermeasures suggest that at least some awareness of the wristwatch capsule's existence had permeated German ranks, although not uniformly. Allied operatives responded in kind. Training protocols were adjusted to include faster access procedures for the capsule, while newer variants relocated the capsule to the watchband clasp for rapid removal. Risk of accidental discovery increased, but so did the likelihood of successful deployment under duress. These evolutions were driven not by central command but by field experience. An agent in Yugoslavia reportedly modified his issued watch to reduce screw-turn resistance on the case back, a detail later adopted by engineers at Station 9. The wristwatch device remained in limited deployment through to the final months of the war. As Allied forces pushed deeper into occupied territories, the role of long-term undercover agents shifted. Sabotage and communication missions were replaced by recovery, coordination, and transition efforts. The need for a self-contained navigation and suicide tool decreased accordingly. By 1945, production had ceased, and surviving units were recalled, repurposed, or quietly destroyed. Yet its impact was not measured in quantity. The wristwatch's operational use was deliberately sparse, its outcomes largely unrecorded. But in the rare moments when it was used, whether to find a safe route through enemy lines or to prevent the unravelling of an entire network through captured intelligence, it served its intended function with silent precision. Assessing the wristwatch compass containing a cyanide capsule is complicated by what is no longer available to examine. Much of the relevant documentation was deliberately destroyed during the war, either to protect methods still in use, or to prevent post-war scrutiny of practices considered politically sensitive. Other records were lost through routine attrition, bomb damage, hurried evacuations, and the quiet disposal of files deemed operationally obsolete. What remains is fragmentary, often indirect, and shaped by institutional caution. This absence of complete records introduces uncertainty at every level of analysis. Exact production numbers are unknown. Estimates range from a few dozen units to perhaps a few hundred, but no definitive ledger survives. Distribution lists are similarly incomplete. While references suggest deployment in France, Belgium, the Balkans, and parts of Italy, it is unclear how widely the device was trusted by handlers or accepted by agents. Some operatives reportedly refused any suicide mechanism, preferring to rely on evasion or endurance. Others accepted the watch without ever confirming its secondary function. Technical limitations further complicate retrospective evaluation. Period testing indicates that the compass component was sensitive to orientation, vibration, and nearby metal objects. Its usefulness depended heavily on user training and environmental conditions. In urban settings dense with steel infrastructure, readings could be distorted. In rural areas, accuracy improved, but only when the user could remain still and level the device. As a navigational aid, it was marginal by design, adequate for short corrections, not sustained travel. The cyanide capsule posed its own uncertainties. Chemical stability varied with storage conditions, and while sealing methods were improved over time, degradation remained a concern. There is no surviving data on failure rates in the field. It appears that planners accepted this risk, reasoning that even partial reliability was preferable to none. The capsule was never intended to guarantee death. It was intended to offer a possibility, under circumstances where alternatives were worse. Ethical considerations were largely absent from wartime technical discussions, but they loom larger in post-war interpretation. The device placed an extraordinary burden on the individual agent, concentrating responsibility for network security, personal survival, and final decision-making into a single moment. Some post-war memoirs suggest that the mere presence of such an option influenced behaviour long before capture occurred, encouraging greater caution or conversely a fatalistic acceptance of risk. These psychological effects are difficult to quantify and were never formally studied. The long-term influence of the wristwatch device is more apparent in what followed than in what it directly achieved. After the war, intelligence services became increasingly reluctant to issue suicide mechanisms. Advances in secure communications, rapid extraction methods, and compartmentalized network design reduced the perceived necessity. Yet the underlying principle, concealment through ordinary objects, continued to shape covert equipment development. Cold War-era escape and evasion kits retained the emphasis on dual-use items that could pass casual inspection while offering critical functionality. There is also evidence that lessons from the device informed counterintelligence practices. Enemy awareness of concealed capsules prompted more aggressive search procedures, which in turn influenced Allied training in resistance to interrogation. The cycle of adaptation and counter-adaptation, visible throughout the war, did not end with this device. It became part of a broader understanding that tools alone could not resolve the fundamental vulnerabilities of clandestine operations. In museums and private collections, a small number of watches attributed to this program occasionally surface. Authentication is difficult. Without serial numbers or standardized markings, provenance relies on circumstantial evidence and incomplete paperwork. Some examples may be post-war reconstructions or training dummies. Others may be genuine artifacts whose histories can never be fully recovered. Their ambiguity mirrors that of the program itself. What can be said with confidence is that the wristwatch compass containing a cyanide capsule was not a symbol of ingenuity for its own sake. It was a response to a specific wartime problem, constrained by materials, secrecy, and the realities of human behaviour under extreme pressure. It did not change the course of the war, nor was it intended to. Its significance lies in how it illustrates the limits of engineering solutions when applied to clandestine conflict. The device mattered because it acknowledged those limits openly. It accepted that capture could not always be avoided, that training could fail, and that technology could only narrow, not eliminate risk. In doing so, it placed trust in the individual agent's judgment at the moment when institutional control ended. That trust, however stark its implications, was central to the way clandestine warfare was conducted during the period. In the end, the wristwatch device occupies a narrow but revealing place in the history of covert operations. It represents a point where navigation, concealment, chemistry, and psychology intersected under wartime necessity. Its legacy is not measured in confirmed uses or recovered examples, but in what it reveals about the conditions under which it was conceived and the sobering calculations that defined clandestine work in the Second World War.